Hi, this is Dr. Prakash, Assistant Professor, Associate Dean Student Welfare Department of Civil Engineering, SR University, Naranda. So today we are going to continue with the surveying geometry. The topic today we are going to see is errors in chain surveying. Okay. So what is called as error? So error in chain surveying is nothing but when you're doing a measurement, so there may be some errors. There are a lot of sources of errors. So primarily your errors in chain surveying are segregated into two types. One is your cumulative error, next one is compensating error, right? So cumulative error is something that when your error is occurring in the same direction and it is accumulated over time. It indicates that some measurements you should be keep on accumulating. The error, whenever you are measuring a distance, that particular error will be keep on accumulating on towards your measurements. So that kind of error is called as cumulative error, right? So this is a curious, I mean, your complicated errors because this error cannot be rectified. So you have to do the entire surveying from the first, right? So this is called as cumulative error. So this has to be found well in advance if you are not noting initially. So the entire work what you have done will be a wrong error because you cannot identify the accumulation of error will be in a huge percentage. Next one is compensating error. So compensating error is nothing but when the error is occurring in both the direction of your measurement. So that is called as compensating error. So here it can rectify. I mean, it can be ignored or it can be rectified when you notice well in advance regarding this, right? So the output of error, the error is positive when the results are too great, okay, and the error is negative when the results are too small. It indicates that your error is indirectly proportional towards your output, right? So one divided by output is indirect because your if your error is keep on increasing, your output will be decrease. If your error is decreasing, your output will increase, right? So this is a major classification of your error. So now we are going to see major sources of error, right? So the sources of error are divided into following type. First one, erroneous length of your chain. So you will be having error length of a chain or tape. Then bad ranging, if ranging is not done properly, so there may be error in your measurement. Then careless holding and marking, this also leads to error on your marking and other things. Then bad tightening, your tape or chain should be hold in well in advance in the straight position. If it is not there, so then there may be error. Then non-horizontality. So your tape should be folded in a horizontal position to measure your distance. If it is not done, obviously that leads to an erroneous measurements. Next, the sag in chain, right? If the your chain is letting to sag, if you're holding your chain in upright position above your ground level, due to the weight of your chain will sag down. So that sag leads to reduction in the measurement, right? So that is due to a sag in chain. Then variation temperature because as your steel tape and your chain are made of iron and steel, so that may expand due to your temperature. So that may there will be variation on your length of your tape or chain. Then variation in pull. So your tape or chain is manufactured at a standardized pull. If the pull is exceeded more than the standardized pull, then it may expand, right? It may elongate. So that is what erroneous measurement. Then personal mistake. So if somebody is telling some measurement and it is not properly noted, and you are not, and the person who is noting the measurement and reading is giving a erroneous output, then that also leads to a error on your measurements. Now we'll see everything in a detailed way. So first we are going to see erroneous length of a chain or tape, right? So this is due to wrong chain length, right? So when your initial measurement, if you're taking 20-meter chain and the measurement is less than 20 or above than 20 meters, so that is due to wrong chain length. So this comes under cumulative error. Okay. So when whatever measurement you're taking on that particular chain, it leads to a length which is misappropriately calculated. Next one is long chain. Okay. So if your chain is too long, then the error is negative, right? Because your measurement what you're measuring it is a too long measurement, then that leads to negative errors. Then if your chain is short, right? If your measurement of chain is too long means actually our chain should be 20 meters, but it is 21 meters. So the error what it occur will be a negative error, right? So if your chain should be 20 meter and it is 19.5 meter, in that condition it's a short chain and your error will be positive error. So to rectify this, a regular calibration needed to be up to apply the corrections. So those things you have to take care. So next one is bad ranging. If your ranging is not done properly, so if your chain is stretched off the line, so if you are measuring a distance and it is not in a straight line and you are stretching your chain in an opposite directions, then that also leads to error. That's due to bad ranging. So this is a positive error, right? The error becomes serious when the offsetting is involved. When you are dealing with offsetting, so this bad ranging will has a huge impact on your measurement. So this is your error caused due to a bad ranging. Next one is careless holding and marking, right? So when you're holding your chain in a careless way and your marking is not done as per the precise way or as per standard, that leads to error on your chain. So this is caused by varying the position of holding on an arrow or a placement. Okay. So you have to place exactly on top of your survey station. If it is not placed exactly on top, you are offsetting some distance, and that leads to error on your mapping and measurements. So this is systematic compensating error because you'll notice well in advance. So this is the compensating error and can be maximized with ordinary cases. Okay, sorry, and can be minimized with ordinary cases because normally you will come to know it is not in the position. Then you will inform them well in advance regarding this, and it is coming. It comes under compensating error. Next one, bad straightening. Okay. If a chain is not straight, there is a bend on your chain, that's a breakage and deviations or bend on your links, that leads to uh, erroneous measurement. The measurement what you are doing with that damaged chain will not be a accurate measurement for your requirement. Okay. So this is measured. This gives you measured distance too great because your chain is too short. That gives you a huger measurement. So this comes under cumulative error and it's a positive error. So because whatever measurement you're taking on that particular bad straightening chain, that will give you a erroneous reading. So this reading will be keep on accumulating, which gives you a huge deviation from your actual, which is on M book and towards your measurement. So this should be avoided accordingly. Then non-horizontality. If a chain on a sloping ground or not hold an horizontal position, that leads to erroneous reading, right? So this will distance measure will be too great. So distance what you are measuring will be too great on these things. So this will be a positive cumulative error. So this is similar towards your cumulative error because your chain is not horizontal. So the measurement what you are taking will be keep on accumulating for whenever you are doing the measurement, and the entire work should be redone to rectify this. So there are some error percentage, some negotiations, or there some deviation, negligence you can do, but if it is done for a huge area, this is will become a cumulative error. Next one is sag in chain. When a chain is sag and when it is not stretched above your irregular ground, so that will come under uh, error and it is a positive cumulative error because your sag in chain cannot be rectified. So if whenever measurement you are taking which is above your ground, that will give error in a reading. So distance appear too great because your chain length decreases, so measurement what you are taking will be too great. So this lead to positive cumulative error on your measurements. Then variation temperature, your rise in temperature, your chain length increases. So that's a negative error. If your temperature decreases, the chain length decreases. So that's a positive error. So this is called as accumulative error because it will keep on accumulating depending upon the variation of your measurements. Then variation in pull. So this is an unequal pull that affects the chain length. Okay. So as I said, your chain are manufactured for standard temperature, right? When there's variation in this one, that will give you elongation of a chain will give you error reading. So this comes under same cumulative error. So the error will be keep on accumulating. For every stretch, your chain will elongate because your chain will is manufactured of by a mild steel or steel. So when it goes from your elastic state towards your plastic state, okay, so that elongation will be permanent. So whenever you are measuring, that will give you a wrong reading. So that thing you should understand and it should be verified. So your calibration of your chain should be done well in advance. Then personal mistakes or displacement. You will be fixing some arrow on the ground which can be displaced and which can be moved, which leads to a variation in your measurement of your survey station, which gives you error reading. So this give you a significant blunder mistake on your entire measurement. So these are the major sources of your error, right? We'll see a diagrammatic representation now, right? So as I said, error in chain length, right? So here you can see this is a 20-meter nominal chain. But if your actual length is greater than 20 meter or your less than 20 meter, that is a error due to chain length. Then error due to temperature, as I said, your uh, um, chain is made up of a steel. When you're during the high temperature, your steel will elongate, right? When you're low temperature, your steel will contract. Then this leads to variation on your measured length, your chain length. Then error due to pull or tension. So if you are giving more pull because your chain is manufactured for a standard pull, right, or tape. So when you are pulling, there may be that's a link, right? There's a possibility of this link to open like this. So which leads to error, more pull. So which leads to chain elongation. So when it is more pull, it is chain elongation. When there's a less pull, your chain will show shortest length. Then error due to sag, as I said, when you are measuring your distance above your ground level, due to the weight of chain, your chain will sag like this. So this is called as error due to sag, right? So error due to slope, when you are measuring a chain, it should be placed on the ground. If it is not done, then obviously there horizontal distance you cannot measure, because if you want to measure horizontal distance, it should be calculated, not measured. So with this measured sloping distance, you can calculate your horizontal distance. Then error due to alignment, as I said, it should be in a straight line. If it is not catching in a straight line, if that deviation, so this will not give you accurate measurement of your thing. So error due to obstacle, if there are some obstacle on your ground and you are including that for your measurement like this, it will give you a error in your reading. So an error due to incorrect counting, because your chain doesn't have a direct measurement on the like tape. So there will be a link which is given. So if you are unable to read that link and measure the distance, that leads to error in incorrect counting. Now we are going to see the tape corrections, right? So the major sources of tape corrections, error in the tapes are: first one is correction for absolute length, correction for temperature. The same thing will be seen here, similar towards your chain. Then correction for pull or tension, correction for sag, correction for slope, correction for alignment, reduction to sea level, then correction measurement in vertical plane. So these are the major sources of error, and some error can be calculated, can be rectified. First one is correction for absolute length. Here we can see the formula is CL into LA minus LN into divided by LN into L. So this is the general arithmetic formula. So LA is your actual length on a tape. LN is nominal standard length of a tape. Actual length is what is your 10th actual length of a tape when you are measuring. And nominal is a standard length what you have purchased. For example, if it's 20 meter, that's a nominal length. The actual length, it may elongate or it gets shorter. That's your actual length. So L is your measured length. So apply positive if the tape is too short. So if you have to make it as if your tape is too short, the correction is positive. If your tape is too long, your correction should be negative. Okay, right? So that is the correction for absolute length. Next one is correction for temperature. So the formula is Ct into alpha into Tm minus Ts into L. Here your alpha is coefficient of linear expansion or thermal expansion, which is given on your questions accordingly. Then this coefficient is calculated accordingly. Then Tm is temperature during measurement, right? During measurement, what's the temperature, and Ts is standardized temperature, because as I said, your manufacturer will give you a standardized temperature and standardized food. So that has to be followed accordingly. That standardized temperature is called as Ts. L is your capital is your measured length. So if Tm is greater than your measured during measurement is greater than your Ts, then it is a positive error. If it is less, it is a negative error. So next one is correction for pull, which is Cp, right? So Cp is equal to P minus Ps into L into A into E. So with the formula, P is your applied pull, P is your standardized pull, which is given by your manufacturer. A is cross section of your tape. You have to measure the cross section. Cross section is nothing but it's cross section which is placed, not into length. Okay, right? Then modulus of elasticity. right? So if it is positive, if your P is greater than applied pull is greater than your standardized pull, then the error is positive error. Okay. Then we are going to see with the correction for sag. So here your correction for sag CS is equal to W square into L cube into 24 into P square. So these are the expansion. W is your weight per unit length of tape, L is your span length, P is your applied pull, right? So this correction for sag is always negative. You can see here, so that variation in about things, but here your correction for pull is always negative pull. Okay, right? So it reduces the effective length. So correction of sag will always reduce the effective length. Then correction for slope, which is your C slope. C slope is equal to L minus root of L square minus H square or H square divided by 2L for small angle. So H is your difference in elevation. L is your measured slope length. Okay. So next one is correction for alignment, which is your CA, CA is equal to D square divided by 2L. So here D is your lateral deviations and L is your measurement. So this is all about your corrections and the formula required for the corrections also. Now we see this in a same thing we have seen here. So correction of standard length, the same formula. So add if your length is shorter and subtract if it is longer. So legends are given here. L is equal to actual length, Ln is equal to nominal length. Same thing. Correction for temperature, correction for pull, correction for sag, which is 24 into P square into H square. And correction for slope is H square divided by 2 into L. So these are the formula what we have seen here. So this is correction for slag and correction for slope. Okay, right? So now we'll see a worked example for the all the correction. Okay. So this is your scenario-based question, right? So you can see that during the layout of a new coastal expressway alignment, a team of surveyors carried out a precise baseline measurement. So they are carrying a baseline measurement using a 30-meter tape. So your length of tape is 30 meters. So it's a steel tape, right? Then it is standardized. Standardized at a temperature which is your TS is equal to 69 degree Fahrenheit and the tension is PS is equal to 47 degree Newton. So these are the standardized temperature. So this is your TS and this is your PS. On the day of field work, the coastal environment was considered warmer. So what they're telling, your environment is warmer than your standard temperature with an ambient temperature rise of 97 degrees Fahrenheit. We can see this is your T. Okay. Your TA is greater than your TH, right? Leading to thermal expansion of your tape, right? So they're indicating due to increased temperature, your tape is expanding, right? So the reclined site composed of soft and uneven sandy ground made it impractical to place a tape directly on surface. So what you're telling, your surface is not in a flatter way. So it is undulation like this. So what you have to lift the tape up to measure the distance between point A and point B, right? So what they're doing to so to maintain linearity, the tape was suspended in four equal span. What you have done, they have suspending your tape in a four equal span. 1, 2, 3, 4 equal span. Okay, the a higher pull of 112 Newton was applied. So what they're telling, so yeah, standardized pull is only 47 Newton, but the pull applied was 112 Newton was applied during the swing length. This adjustment minimized deflection but introduced additional elongation due to increasing tension. What they're telling, it is suspended in fourth one, but it minimized your deflection, but it increased the tension. So despite of these effect, even though you are applying, there is a minor sag which is remaining because the tape self height it is there due to the self height of your tape, that's a minor sag, right? So the steel shape here comes the required data. I mean your given data 70 unit weight of steel is 17 kilonewton per meter cube. Cross sectional area of your tape is 8 mm square and modulus of velocity of steel is usually 2 into 10 power 5 Newton per mm square. And the coefficient of thermal expansion is 6.94 10 power minus 6 per degree Fahrenheit, right? So these are the data required for your calculations. Then, so after doing all these things, the measured baseline was 197 degree meter. So what you have to do, you have to do all the corrections and identify whether your measured length is accurate or not, and how what is the correction after your correction, what is your actual measured length. So that is the question. What as a part as a surveyor, you are supposed to give the solution for the above question. So steps in calculation, first we are going with the calculation temperature expansion with the thermal expansion. right? So alpha is equal to L naught into alpha L into theta T. So L naught is equal to 197 meter and alpha is equal to 619, theta T is equal to 97 minus, so variation temperature 97 minus 16, 28 degree Fahrenheit. When you are applying this, you will get an answer of temperature correction is 0.038 meter. You can clearly see that the correction is only minimal. So per tape length it is 0.038 meter. By applying the formula, you got this answer. So the tape is elongated. So there is variation temperature, right? So if the temperature increases, this is a positive error. So you have to add it with the measured length. Okay, right? Your tape is elongated by 0.038 meter due to the temperature rise. So your first correction for temperature is done because your tape is elongated. You can see here. So the difference between your temperature change is positive. So it is a positive error. Okay, you have to add it from your total measured distance. So going to the next one, you are going to calculate the elongation due to tension, right? So this is very important part what you are going to see because the elongation caused by increase in tension, it can increase using a Hooke's law. So we are applying Hooke's law for elongation under the tension. So the formula is F into L naught divided by A into E. Okay. So F is the applied tension, which is your P, right? L naught is a measured base distance, what you have measured accordingly. Okay, right? And A is a area of mm square. Okay, so 8 into 10 power 6 mm square cross section area, and E is because it's made of steel, right? So mm mild steel, so it is 2 into 10 power 5 is a standard which is applied. So when we are converting that to meter, because why we are converting is because your length is in meter and A is in mm square, so that mm square has to convert it. How we are going to convert is mm square into meter square. So 1 meter is equal to 10 power 3 mm. Okay. So this mm will clearly give you, so that is m square, so 10 power minus 6 because a millimeter to meter, it has to be divided by 10 power minus 6. So you are getting 10 power minus 6 as your cross-sectional area. Then E is equal to 10 power 5 Newton per mm square. So here converting this to Newton per mm square, mm2, because here it will come into 10 power minus 6 when it go up, so it comes 10 power plus 6. So 5 plus 6 will get 2 into 10 power 11 Newton per meter square. So that is the molecular velocity. When you are applying everything on this particular formula, so which is 112 into 197 will give you the tension loading because this is your applied pull. So this is your applied pull, and 197 is the measured distance, which is which is your actual measured baseline. Then here, this is your cross-sectional area, right? A is your cross-sectional area, converting that to meter square. So it is 8 into 10 power minus 6 into 2 into 10 power 11. So the answer what you are getting, if substituting this in your calculator, the answer is 0.035 meter. So the elongation due to the increasing tension is actually calculated accordingly, which is 0.035 meter. This is a positive error. So this is the elongation because your standardized elongation is 97. Here your full is 112 Newton. So accordingly, you have to use this for your calculations. So next one is calculation. Uh, Calculate the sag or to self height. So you are going to calculate your sag towards your self height because we are tape is suspended on four equal spans. So even though if you are pulling in that question, you are clearly saying even though due to the pull because it is suspended on four equal spans. So it has an 1, 2, 3, 4, 5. So the four equal span it is suspended. Okay. So this is equal span 1, 2, 3, and 4. Right. So with this four equal span you are calculating. So the formula is W L naught divided by 8 into T. So T is your applied load, L naught is your measured length, W is a unit weight of tape. Right. So the thing first you have to convert your kilonewton per meter cube to Newton per meter to the foot. So your W is equal to 78 into 10 power 3 Newton per meter cube. Now we are substituting all the entire measurement on this. right? So which is 78 into 10 power 3 into 197 square, that's your measured length, divided by 8 into 112, right? So you'll get an answer of 0.072 meter, right? So this is a negative, as I have given, this will be always negative because your tape is sagging. So your tape will sag in all the four spans, right? So your tape is keep on sagging on all equal spans, so you have to calculate accordingly. So for each sag, it will be a negative. So depending upon the each sag, so this is your sag, so your measured distance will get reduced, right? So this correction should be always negative, which we have seen earlier in the formula sections, right? So the final adjustment of measurement, what we are going to do is, so the measured length is affected by temperature elongation. First, we have calculated the correction for temperature, and it is value of, and it is 0.038 meter, and there is a tension elongation because you're stretching your tape for the tension, so which is 0.035 meter. So both are positive error, okay, because you got your temperature already in a positive way, so we are adding this here, and this is your tension elongation is also in a positive way, so we are adding this also, right? So as I said, because your why this is positive? Because your temperature on your site is greater than your standardized temperature. So this is positive. And similarly, your tension, what you are pulling on your site is more than when compared to your standardized temperature. So both your answers will be positive. You don't want to change any sign. If it is negative, automatically you'll get an answer in negative. So here this is also, if it is less, you'll get an answer in negative. But here you are getting a positive, which indicate it is a positive correction. And finally, the correction for sag is negative because as per your standard, every time this sag will be always negative correction. So the total elongation due to temperature and tension, first you have to calculate a positive tension. So what we are going to do is alpha L is equal to total positive error. So first we have to add the temperature and tension elongation. You can see here. So this is a alpha L for temperature. So this is 0.038, which we have calculated earlier. And this is a correction for your tension, which is 0.035, which is already calculated earlier. So as I have said, these both are positive, so we are going to add this 0.038 plus 0.035, which gives you a positive correction of 0.073. Okay, right? So this is a positive correction. Okay, so this correction should be added with your total length. So your total measured length is 197 meter. So this correction should be added. Then final adjustment we are taking because there is another one correction which is called as correction for a sag. So this is always negative as I indicated. Due to the sag, there may be reduction in the measured length. I mean, there will be reduction in the tape length. So that will give you always a negative error. So that error will always subtracted from your measured length, right? So this is an was negative correction. So which is negative, which is 0.072. Okay. So the true length, what you are going to do first, your measured length is 197 meter, which is measured using your tape, right? And this is your correction for temperature, which is positive. Sorry, this is correction for temperature and tension, which is 0.073. We have added this already. So we got the answer of 0.073 and we are adding that correction. And as I said, your sag is always negative. So we are subtracting that 0.072 and your final answer is 197.001 meter. Okay, right? So this is your final correction. You can see that is only minimal correction because your length is 197. So the correction is very minimal, which is less than the correction. Obviously, if we convert this to meter, so 197.001 into you'll be getting 1000, you'll get an answer of 197. When you convert this, the correction is only 1 mm. Okay, you can see that the correction is only 1 mm. When you are measuring this thing on your tape, this 1 mm doesn't have a huge impact because Here it is 1 mm for your calculation we have done. When you are doing for a distance of make it as 197 1970 meter accordingly, then it leads to a huge corrections, right? So this is very minimal corrections. So the distance is very less when comparison to us because it is less than 200 meters. So that's why you're getting a very minimal correction. Normally, this correction will be huge when your measured distance is small. Okay, right? So this is all about your correction and the problematic how you are going to substitute a correction on your calculations, right? So thank you. Thank you with this. I hope this session will be informative for you and thank you again.